In this video, we'll be looking at another way to solve polynomial inequalities without sketching the graph, and that is by doing a sign analysis chart. So we're going to do two examples here, one that's already been factored for us and one that hasn't. So just like with any regular polynomial inequality, one side has to be 0. The polynomial has to be factored so we can find the zeros. But this time, instead of sketching using our zeros and our end behaviors and the degree, we're going to create a number line with those x-intercepts. So in this first example, it's already factored. Our zeros are 0, 3/2, -3, and +4 from our factored brackets. Now, I'm going to create a number line here from -infinity to infinity, and I'm going to place these zeros on the number line in proper order. So we have -3, we have 0, we have 3/2 or 1.5, and we have 4. And I'm going to create a chart here. And then I could take all of these factors and write them in a separate column. And the very last one will be final or overall. Now what we're going to do to test, we're going to pick a value within each interval and test its sign within each of the factors. So for example, between -infinity and -3, I'm going to pick a test value of -4. I'm going to plug in -4 into each of these factors, and then I'm going to look at the signs to get the overall sign of my function. Now, this is just one way to organize your sign analysis. You can do this all in one go. You can take -4, plug it into the whole function, get your overall sign right away. This might just be a little faster because you could just use mental math. So for example, -2, and then I'm going to do -4 squared. Well, -4 squared is +16 times -2 is a negative number. I couldn't care less about the actual value. I just care if it's positive or negative. Then 2 times -4 is -8 minus 3 is -11, so that's a negative. -4 plus 3 is a negative number. Cubed is still negative. And then -4 minus 4 is -8. I have 4 negatives there. If I multiply 4 negatives, that will be overall positive because each pair of negatives becomes positive. Let's try another one. Between -3 and 0, I'm going to pick -1 as my test value. And actually, I'm just going to make this easy. This factor here, regardless of what number you plug in, will always be negative because x squared will always be positive times that -2 coefficient. It's always going to be negative, so I'm just going to save time doing that. Then 2 times -1 minus 3 is -5. -1 plus 3 is 2, cubed is positive. -1 minus 4 is negative. Now I have these turning positive and we still have a leftover negative, so the overall sign of this function will be negative between -3 and 0. Now I'll test 1 between 0 and 1.5. So that's going to be 2 minus 3 is negative, 1 plus 3 cubed is positive, or 1 minus 4 is negative. This, once again, is going to be negative because we have 3 negatives. An odd number of negatives will be overall negative. Next, between 3/2 and 4, I'll pick a test value of 2. So that's going to be 4 minus 3. That's now positive. This is positive. This is negative. We have 2 negatives. That forms a positive. And finally, something greater than 4, I'll pick 5 as my test value. That would be 10 minus 3 is positive. That's positive, and this is also positive, which gives us an overall negative sign. Now that my sign analysis is done, I go back to my inequality and see what I'm testing for. I want to be less than 0, which means I want this this, and this. I want the negative intervals. So now let's see. I want to be between -3 and 0, between 0 and 3 over 2, and from 4 onwards. Now, because I'm not equal to 0, I don't want to actually include these x-intercepts. So I'm going to write my statement now and say that this polynomial is less than 0. So we'll just say y is less than 0 when x belongs to the interval from -3 to 0, and from 0 to 3 over 2, and from 4 to infinity. And there we are. And that's your sign analysis. So for the next one, we do have to factor it first. One side's already equal to 0, so that's great. But I noticed that there's a common factor of 2. So let's go ahead and factor that out. Minus x squared minus 8x plus 4 is less than or equal to 0. Now we need to find a factor for this polynomial in the bracket. And if you plug in +2, we're going to get 0, which means x minus 2 is a factor. So I'm going to do my synthetic division here, although long division is perfectly fine as well. And here's the check that I know I've done it correctly because I got 0 for my remainder. So when I write what I'm left with, don't forget your GCF, the x minus 2 factor, and then this remaining quadratic. And then I'll just do a quick crisscross or whatever factoring method you want to do. And I will get 2x minus 1 and x plus 2. So our zeros are 0, 2, 1/2, and -2. That's what I'm going to put in my number line. -2, 0, 1/2, and +2. And my factors, 2x, x minus 2, 2x minus 1, x plus 2, and the overall or final. Okay, pick some test values. So I'm going to use -3, -1, 0.1, let's say, 1, and 3. That's what I'm going to test. And this time I'm just going to test each row at a time because that actually does end up being faster. So 2 times a negative number will be negative. 2 times a positive will be positive. Then for x minus 2, for any number less than 2, we're going to have a negative number. The minute we go beyond 2, we'll become positive. So -3 minus 2, negative, 1 minus 2 is negative, 3 minus 2, that's when we finally get positive. So this can be really quick without a calculator. Then for 2x minus 1, I'm going to be positive once I get past 1/2. So this is going to be negative, negative, negative. When I get to 1, I'll have a positive number, and 3. For x plus 2, that's negative, and the minute I hit -2, I'm going to turn positive. And now we could look at our overall sign. So here we have 4 negatives, that'll be positive overall. And the next one I have 3 negatives, so that will be negative overall. 2 negatives, that's positive. 1 negative, that's negative, and all positive is positive. And now what are we looking for? We want to be less than or equal to 0. So that's here and here. Now the fact that we're also equal to 0 means I can also include my x-intercepts. So when I write my intervals, I'm going to say y is less than or equal to 0 when x belongs to the intervals -2 to 0 including them, and 1/2 to 2 including the values. And there we are, another strategy for solving polynomial inequalities. We still have sketching, of course, but now we have the sign analysis.